Hello everyone, welcome to my channel. This is Upesh. Hope you're doing perfectly well. So today, what are we going to take in today's session? So we have done a lot of topics on Grafana Alloy, Kubernetes, and so on. But the recent topic that came to my notice and came to my notice from my one of the the few users that how to do a complete end-to-end Kubernetes monitoring. So Grafana is providing a very good Helm chart, and we can do that, 360-degree level of Kubernetes monitoring. Can be any Kubernetes, whether it is the EKS, Elastic, Amazon EKS or Azure EKS or any bare metal Kubernetes cluster. But for that, we need to follow certain steps that we'll be checking it today. And that Helm chart not only will do the manufacturing monitoring, it will do the application level monitoring also. So let's see what we have in today's lecture. And this is my small GitHub page that we'll be using in today's lecture. Yeah, I'm talking about this GitHub page, and I'm talking about this, you know, the article. You can see the configure Kubernetes monitoring with easy deployment of Helm chart. So we'll be talking about this article only and how we can see the infrastructure, application level monitoring, and so on. Basically, the complete package, right? So I have a Kubernetes cluster. I want to monitor this cluster with the help of single Helm chart. I don't need to worry about the other Helm charts like node exporter and application configuration and so on. So let's see how we can do with the help of Grafana Cloud pretty easily. So first of all, I need to go to my so I have a GitHub page for this. We'll be following this GitHub page, but before that, this is my Grafana Cloud account. I'll just go to home and we'll be following that documentation one on step by step. So yeah, I'm talking about this documentation. So first of all, if you don't have a Minikube cluster, you can simply install a Minikube cluster with this documentation. And if you have any other cluster, that is perfectly fine. Now, we need to go to the configuration of Kubernetes page of Grafana Cloud. So this is my Grafana Cloud I'm talking about. I'll come here, I'll click on the infrastructure and I'll click on the Kubernetes. And this is applicable to any of your Kubernetes cluster. It is not about Grafana sending data Grafana Cloud, but you can send this data to your any local Grafana, Prometheus, Loki, and Tempo, right? So I'll go start sending data and then I'll come onto this page, like configuration page. There are certain prerequisites. You should have a kubectl helm command installed on your cluster, which is fine. You can install the alert tools and recording rules. Click on this button, and then this alert tools will get installed into your configuration of Grafana. Now, what next? What is next? Okay, so I need to give any cluster name. I'll give the test cluster, right? I'll give the metrics namespace. Perfect. Now I'll enable the application observability. Basically, what does this radio control will do? This will help us to install the Beyla Helm chart also, which will do the application level monitoring. And then it'll do the auto instrumentation. Perfect. And then I'll click on this. I'll give some name for my token so that it will generate the policy token and it will send the data to the Grafana cloud with that token, basically a remote write token. Okay. And then I'll click on the Helm option. Then I'll get this, piece of code. I'll just copy this thing before installing it. I will just paste into a node plus file and we'll try to understand what is happening. So I'm saying, please do a repo add of Grafana as a repository and then repo update and then finally install helm upgrade install version. And this is the name of the Helm chart. Okay. From this repo in the namespace matrices. And these are the values. Now understand the values. So cluster name is test cluster, external services where the matrices should go. The matrices should go to your Prometheus remote write endpoint. Now you can change this Prometheus to your own Prometheus. Okay, that is what I'm trying to say. And then you can give the username and password if it contains. Otherwise, you can skip it. And then give the Loki for logs and tempo for tempo. Perfect. Now moving on. What we are trying to. So metrics enabled is true. Alloy. Alloy is the agent that will receive the data from cluster. Okay, I'm enabling the cost. Now this is a Grafana cloud feature that will tell you how much cost is being saved and how much cost is being, leveraged, or you can say how much cost has been. So basically, they're using an open cost, Helm chart for this. Kepler node exporter is for capturing the infrastructure metrics. I'm enabling true. Beyla enable true means it will do the auto instrumentation of certain applications that are installed in across the namespace, and Beyla will get installed as a daemon set. Right, you can watch the Beyla related videos in my different playlists. But yeah, in this Helm chart, Beyla is also getting installed. So what all other Helm charts are getting installed? Alloy, Cost, Kepler, Node Exporter, Beyla, and logs are also getting enabled. Pod logs are enabled. Cluster events are enabled. Now traces are also enabled. Now what are the receivers? Now this is for application level monitoring. Now in this Helm chart, what I'm saying, please receive all the application level data into the gRPC port, which will get enabled as a service. And the kubestate matrix is also true. This will install kubestate matrix Helm chart, Prometheus node exporter, and so on. So let's run this thing onto my cluster. Let's see if this is running or creating any problem to me. Okay, so it will install the Grafana Kubernetes monitoring Helm chart or release name into my metrics namespace. Okay, and once this is installed, now we will install one sample application also, just to understand how my application is behaving. So this Helm chart will serve both the purposes. It will do the infrastructure monitoring as well as the application level monitoring also. Now this Helm chart has been installed. I'll do HL. Okay, Helm get values. So I can see what are the values that have been passed in Helm get value. So I can clearly see the Beyla is enabled. Cluster name is this. This is the Locky endpoint, Prometheus endpoint, and then we have a tempo endpoint. Kubeset is enabled. Whatever we were saying. Now let's see the pods. Okay, KGP. How many pods are running? So I have a monitoring alloy, which is an agent which will gather the data. I have a Beyla pod also that will do the auto instrumentation. I have a CubeSat matrix which will expose the C advisor matrices, the pod level matrices, and the Prometheus node exporter, the infrastructure level matrices. Okay, and let's see key get all. So I was explaining you that alloy is being installed as a stateful set, and then we have monitoring alloy events as a deployment set. Open cost again as a deployment set. Let me delete this application that was there. We'll install this application again. I'll do again get all. And then let's see the daemon set. What all daemon sets are there? The Beyla is a daemon set, Capital is a daemon set, and the Prometheus node export is a daemon set for capturing infrastructure data. This is for capturing application data, application level monitoring. These are the different services, right? Now let's see. So let's see the services. Okay, get services. So I have a Alloy as a service running as an agent, which will expose the gRPC port of 43174318. Then we have a cluster level service, events, logs, agent. Then CubeSat matrix. CubeSat matrix is nothing but to, let me show you the CubeSat metric. What does it contain? It will contain the C advisor level data. Right. I think most of you are aware about it, but still let me just show you what this CubeSat matrix film chart is doing. It will capture your C advisor level data. Yeah, CubeSat matrices. All the C advisor, contain advisor related data is coming back here. This is the one of the thing. Now, what are the, let me do the node exporter. I think node exporter, most of you are aware. It is a mm, infrastructure, pulling the infrastructure data basically. right? Let me go back and then do 9100. Okay, so this is the infrastructure data. It is, and in the infrastructure data it will pull, and perfect. Now let's see what are the pods are coming. KGP, Hello events logs, Beyla, perfect. Let's install one another application. I'll go to my this folder, CT app monitoring. Uh, okay, I'm already in that folder. Fine. And what do we have in this folder? Uh, it's a Python-based instrumented application. I'll be given this name is like this. Okay, service name. Now, this instrumented application will emit metrics, logs, and traces. But you see the difference is I have given the OTLP endpoint, which is this one, which is the alloy service in the metrics namespace cluster router with 4317 port, and you can see the same thing in your documentation also. So what they are saying, configure application instrumentation. After Helm chart is deployed, you will need to configure your application instrumentation to send the telemetry data to Grafana Alloy using one of these addresses. So I have copied this addresses, complete address, and then paste it into the OTLP endpoint. So basically, application level instrumentation data will be captured by Alloy directly. That is the reason I'm installing this application, right? So I'll come here and then I'll install this application. I'll go back to cluster. Okay. Now I'll go back. I'll see KGP. The pod has started running. Get SVC service. The service is also running. K port forward. I'll do some hits on the service. It's okay. So 8080 and then dock. Okay, let me see. There's some problem. K get SVC K del. I'm just deleting that pod again just to make sure that it is getting the latest data. So I'm reinstalling or reinstating my this Python based service KGP. Yes, now the new pod is running. I'll see the service also. Okay, get SVC. And just do it again. Perfect. So I'll do KGP. Pod is running. Okay, get SVC. Okay, port forward. Single app collector 8,000 30,000. Okay, so there was some problem in the port. So I have port forward the port again. So this is the service I was talking about. So Python based application, I'll do some hits so that it should generate the metrics, logs, and traces, and then we'll see everything on Grafana clouds. Okay. Mm, Now I'm just going a bit slow because this is a little bit complex topic. So what have we have done? Let's do a quick recap before you go to Grafana cloud on understanding. So there's a cluster we have installed this, the biggest Helm chart, which will install your Bela, your node exporter, everything, the infrastructure side and the for application side, the application instrumented data will capture the results from this endpoint. Okay, this endpoint. So I need to configure this endpoint into my instrumented application, which is the Python based application. Also, Bela will do the auto instrumentation for other services that are there. So this is the URL that I pasted here, right? And I've given some name. And then this should start sending the data now to Grafana Cloud. Now let's go back and check the Grafana Cloud. What is the next step to validate? The next step is simply validate the matrices on Grafana. So I'll just run this magic query. It will tell me the distinct jobs pertaining to. Now uh, I'll go to the home page of, and I have followed all this article that has been mentioned with the help of steps. So now I'm going to the explore section and we'll see the distinct matrices for last 15 minutes or so. Let's see. Okay. Interesting. We are getting a lot of data now. The hell amount of data. So we'll understand one by one. So okay, we have installed node exporter. These are the node exporter. See, you will see integrations as a slash, because you have done the integrations using that Alloy Helm chart. So node exporter data is coming. Open cost data is coming. Okay. And all these metrics slash, these are all your Bela related matrices that are coming. And let's see what is C advisor data is coming. Integrations, a lot of integrations. Cube state matrix is coming. Okay. Cube monitoring telemetry data is coming. Open cost is coming. So this is from the I mean it is doing the very detailed level of your Kubernetes infrastructure monitoring. Now let's see this thing in a greater detail using before you go to there, let's see the log key logs. Okay, do we are writing any logs or not? So I just simply say, suppose I'm talking about cluster. So this is the cluster that I gave, the test cluster, and then I'll just select the namespace because I've enabled the pod logs also. I'll select the matrix namespace, then I'll select um, the pod. Okay, I want to get the suppose Bela pod data logs. So I'll get all the logs that are coming to the Bela, right? Bela pod or basic. This is test cluster and everything so on. Logs are also coming. Now I'll go to the traces part. Now traces, I'll first of all check my auto instrumented, one. See, I think this is the one, right? Instrumented app. So I'll just do this. I'll see if there any data coming out of it. Yeah, so instrumented data is getting, this is my Python application, which is sending the data to traces. This is a particular trace and I'll click on the logs. This will take me to the logs. So you can see there's a proper marriage between logs and traces with the help of trace ID, and this is the already instrumented application. But if you select any other application which is not the auto instrumented, basically the application which is instrumented by Bela, that will not give you the logs because Bela doesn't give you logs. So suppose if I click this, you might get the matrices and traces, but you'll not get the logs. Suppose this is the trace I was talking about. If I click this, I'll get the detail span section, but I'll not get the logs because Vela as an auto instrumentation doesn't give you logs. It will only give the metrics and traces. So that you can check in my previous playlist on this section. So what we have seen in the traces, we are getting both the traces. The traces generated by Vela as well as traces generated by the auto instrumented app. Okay. And you can see the other stuff also. Node graph is not there. So, okay, let's go back now. I want to show you the very important thing of the infrastructure page. So we started from here, we click here, and then we get to the configuration. And then see, now you can see the entire overview. I have one cluster. This is an automated dashboard generated by Grafana Cloud. So I have one cluster, one node. I can click on nodes also. And yeah, this is my test cluster or my cluster for that matter. Okay. And then I'll go to this cluster. and I can get the cluster CPU, cluster memory, CPU cost, memory cost, total cost, CPU idle cost. All costing is also coming nicely. Now I'll go back. I'll go to the network. I can get the network bandwidth saturation, network bandwidth by node, saturation by node. I'll go back. I'll go to energy now. I can see the energy also. So this is what I was talking about. This is a complete monitoring that you will see it on this Grafana Cloud option. And I can see logs and events also for that cluster. Right, I can set up any alerts and then go back. I'll just come back to this. I'll come back to that page. Names we have seen. Let's see workloads also. So we can see all these workloads are there. Demonstrate deployments. I can click any one of them workload and I can get the details of that workload. What is happening? Right. Correct. Now let me go back. Let me see what all things are there. Mm, let's see these nodes you have seen. Let's see the cost. This is again an important item which Grafana Cloud is giving. So they are providing the cost of last 30 days, and then they are providing the total cost of next 30 days. Okay, a total cost, and then they are providing savings also. How much saving CPU cost, CPU saving. This data is being generated by that open cost Helm chart. So if you see that documentation, you'll find that open cost Helm chart is doing this all this magic, right? And then I'll come back. Correct. I'll just scroll down. We have alerts also. You see, I enabled alerts, so you can definitely there's no firing alert, but you can get all the alerts that are there. I install those alerts. Mm, since there are no alerts for now, but the alerts have been installed. So you can check the alerts from here also, alerting and then alert rules. Right? Yeah. So these are all I went through alerting, alerting, and this is the alert manager based alerts. There are two alerts, Grafana manager and alert manager based. So we have installed the alerts from backend. So these are the all alerts that has been installed, from that chart, right? This is the queries that is being monitored. I'm going back. Alerts are done. Yeah, configuration we've already checked. This is how you configure your monitoring. This you have already done. See your cluster status. Now you can see my cluster status is last. This new cluster test cluster is one. Yeah, this is the one. So last 15 minutes, I'm getting the monitoring Helm chart, alloy, node exporter data, all these greens. I'm getting the seed weather data also. I can see open cost is also giving data. You can get the documentation of this open cost from here, manager configuration, right? So pod logs, Kepler logs, job level. Windows exporter is not there because I don't have Windows, exporter, Windows node for that matter. Otherwise, the Windows data will come. So this is how you can see the integrations testing, and I can see the cardinality also, like how many matrices are irrelevant and not relevant, right? This is the cardinality of matrices that you can see. See, count of series, duration cycles, three distinct. Top matrices for test clusters, so I can see the cardinality also. So that is the reason I'm saying just explore each and every option of this infrastructure. Now we explored everything. Now we'll go back to the application side of it because we have done the application level monitoring also. Okay, last 15 minutes for that matter. Or let me put last 30 minutes. Now you see, the moment I installed Beyla, it has enabled application level monitoring. And if I click single app collector, this is the one which is the application that I have installed. And let me give you last 3 hours of data. So last 3 hours of data, I can get the data also. And yeah, that is pretty much I can get the traces also. So in this, I'm getting the application level traces, and then I click on the logs. I will go to the logs also, right? Unfortunately, there are no logs, but yeah, you can get the traces, services. Okay. Suppose I want to see If I want to see some other matrices also, let me check the Beyla matrices. So I mean, you need a lot of time to explore each and every matrix. This is a Go related matrices. Like suppose you want to see the open cost, not open cost. Suppose something else, node exporter. Suppose okay, this is a matrices or this is a service that is running on this namespace, right? So let me do it for last 3 hours. You will get some data. Yeah, the node exporter data you can get. The red matrices, okay. Rate, error, duration. And there's one more thing which I want to tell you that not only from this section you can, if you have open source Grafana, then you can install the Beyla dashboard also with this, 19, and you will get all these details in a dashboard also. So how to do that? So come back, new, import, dashboard, load, load. Okay, just giving different names so that should be unique. Now this is the I was talking about that Beyla red matrices dashboard. So you can see the core DNS service. It is giving the duration of 99% that 95% average HTTP average time. You can see in microseconds and then request rate. This is for next service. This is for another service, and whatever service is it, they let different tile for that service, right? And then you can see the open cost and so on. So if it is not mandatory that you should have a Grafana cloud for that, you can add this dashboard also as a no basically for your monitoring, right? So I think I've covered almost everything. I've covered infrastructure, I've covered the application level monitoring. Correct. So that is pretty much. I know this session was a bit. I know this session was pretty lengthy, but what we were checking there, we were checking two important things. First of all, we are checking the infrastructure monitoring using the single Grafana Helm chart, which is a beautiful Helm chart that does tell you about installation of different exporters and then collating all that data and sending it to Grafana Alloy agent and then further sending it to Grafana LGTM stack. Next thing which we did was your installing the application level monitoring using Beyla, and then we were collecting all that data from an Python based application and sending it to Grafana Cloud using the gRPC port, the second section of the Grafana Cloud configuration. If you remember, I'm talking about this PC. I'm talking about this section. So yeah, just to uh, cut short, this is what I was trying to say that Grafana Helm chart can do the complete level monitoring. It is all a matter of installing it and then using it either as your own Grafana, own Prometheus, own Loki, own Tempo, or you can do ship everything to the Grafana cloud. And I think that is pretty much. Let's take a bit pause. If you have any doubts and queries, do not forget to put down into the comment section. This is my YouTube channel. If you want, you can get all the other config, other
Hello everyone,
videos
welcome to my channel.
related to Beyla, um, related to OpenTelemetry, related to Grafana Cloud, AWS, and so on. So just give it a try. Give it a try on this channel. If you find it useful, share it with your friends and colleagues. And I am would like to understand any trickiest and toughest use case so that I can do a next video on that. And till then, goodbye. Do take good care of you. And till then, goodbye. Bye bye.